Hello, I've called this video One More Trig Equation because I know I've done solving with trig equations in some past videos. This one I picked though because it has in it a 3 theta right there. So our first step in part A, finding all solutions, I'll just recopy this. We need to get sine of 3 theta alone, so I'll add 1 to both sides. That equals 1, and then divide both sides by 2. So sine of 3 theta equals 1/2. All right, so now let's just kind of ignore the 3 theta for a second. I'm going to write over here that 3 theta equals, and then we're going to fill in what it does equal. This right here is the same thing as saying sine inverse of 1/2. So this is the type of problem where, without using a calculator, you need to think through the quadrants. Sine is positive both in the first and in the second quadrant. And a sine inverse of 1/2 means that opposite is 1, hypotenuse would be 2. So you can see this starting to take shape. This means this would be rad 3. So this angle in here would be 30 degrees because it's across from 1. But better than that, we'll say that it's pi over 6. So the very first thing I need to write back over in my solution is that 3 theta equals pi over 6. And what else? The other thing I write with this is I write plus 2 pi n. Because it doesn't only equal pi over 6. Think about if I'm at pi over 6, but then I swing all the way back around the circle again and get back to that same spot, that would be a total of 13/6, which would be another answer. 13 pi over 6 would be another solution. So by saying pi over 6 and then adding 2 pi n, I cover all my bases for all of those answers. Now, in the second quadrant, it's still a 1, 2, rad 3 triangle. So the answer in the second quadrant to go from 0 over to there, that is a total of 5 pi over 6. So 5 pi over 6, and same thing, add 2 pi n. That would be listing all of the infinite solutions. Now the only thing is, this is for 3 theta. So what I need to do is divide everything by 3. Divide by 3. That looks a little bit funny, but I'll move this to where we have more room. So now I'm going to get theta equals pi over 6 divided by 3 is pi over 18. It's the same thing as multiplying by 1/3, if that helps. And then that's plus 2 pi n, also divided by 3. And then the other thing that theta equals is 5 pi over 18, because 5 pi, let me just write a little note, 5 pi over 6 divided by 3 is the same thing as 5 pi over 6 times 1/3. And that's how I'm getting 5 pi over 18. And then also for that one, it's plus 2 pi n over 3. So circling this, that would be the way that you would answer part A, which was asking you to find all solutions, because technically there is an infinite number of solutions, because you can just keep going around and around the unit circle and getting more and more answers. Now to do part B, where you're finding the solutions on just the specific interval, you can use your answer to part A. Let's recopy that. The theta was pi over 18 plus 2 pi n over 3. But it was also 5 pi over 18 plus 2 pi n over 3. We're going to use that to find the answers that are from 0 to 2 pi. Just get rid of this extra work. All right, so what we do, first of all, how about 2 pi n over 3? Let's change that to a common denominator, which would be adding 12 pi n over 18. Okay, so that's what we'd be adding instead, just so that we have a common denominator. So now let's think if n is 0, then our answers would be just pi over 18 and 5 pi over 18. That's pretty simple. Actually, I should probably write it here, 5 pi over 18. So those would be the two solutions if n was 0. Now, let's write when n equals 1, I would be adding pi over 18 plus my common denominator, 12 pi times n, but n is 1. Let's write that though, 12 pi times 1 over 18. That adds up to a total of 13 pi over 18. And then same idea with the 5 pi over 18 plus 12 pi times 1. That adds up to 17 pi over 18. So I just got 2 more answers. So far, those are 2 answers. These would be 2 answers. Now I can go all the way up to 2 pi, which with a common denominator is a total of 36 pi over 18. So I can still do one more value of n. So let's say if n equals 2, let's just see if our answers still come out small enough. So if n is 2, I would take the pi over 18, and I would add 12 pi times 2 over 18 onto it, and that would give me, so that's this right here, that's 24 pi. So that gives me a total of 25 pi over 18. That's still small enough, so that's an answer. And then if I do it with the 5 pi portion, so 5 pi over 18 plus 12 pi times 2 again, 18ths, that's adding 24 pi again, so that adds up to a total of 29 pi over 18. That's still small enough. That's still less than 36/18. So now I have a grand total of 6 answers, and that is actually all of the answers. Normally, if you have a 3 theta, then you can expect 6 answers on the interval 0 to 2 pi. Now, if you weren't sure if you could go again with another n, you could plug n equals 3n. And I'll just show you how that's going to come out too big. There's a little space right here, n equals 3. Let's say I take pi over 18, and I try to add 12 pi times 3 over 18. Well, here's the first problem. Pi over 18, that's adding 36 pi over 18. And that's already going to be too big, we can tell, but that adds up to 37 pi over 18. But remember, 2 pi, I erased it to make room, but 2 pi is a total of 36 pi over 18, so 37 pi over 18 is too big. So we know that we've done all of the n values that we could. N equals 0, n equals 1, n equals 2. They all gave us legitimate answers that were between 0 and 2 pi, and that's everything. Plus on top of the fact that you can expect at the beginning of the problem that you would have 6 total answers for part B. And so those problems are a little bit harder, so I would suggest practicing with a few more out of your book that have a 3 theta in them, maybe a 4 theta. If there's a 4 theta, then you can expect to have 8 answers. I'll make a little note of that. 4 theta, you'd have, in most problems, 8 answers. There's some exceptions to that rule. And then 2 theta is another real common problem that they give. You would typically have 4 answers. And that's for the ones that are on when you're listing them for 0 through 2 pi. And hopefully that will help.